Hi everyone, hope you're doing great. Hope you had a wonderful weekend. Glad to be back with you. So we are just going to continue with our stoichiometry stuff. So let me let you know kind of where we're at here. As you know, we had before we left school, we had learned all about our mole problems and we were able to go from mass to moles. Nothing is drawing. Let's see what's happening. There we go. We were able to go from mass to moles. Over here, mass to moles, moles to mass, moles to volume, volume to moles, moles to particles, particles to moles. We knew how to do that. Then last week, we learned how to do this moles A to moles B step. And this is a step that made something a stoichiometry problem. We do that step to switch substances from A to B. That always involves our mole over mole step. And then we know how to go from here to here to here and so forth on this side. Now, what we haven't actually practiced with stoichiometry yet is actually using the particles part. So you guys have done some problems that go mass A all the way to mass B. You've done some problems that go like mass A to volume B. You've done some problems that go volume A to volume B. And of course, you've done some like just moles A to moles B, some one-step problems. But what we haven't really worked with too much is these particle problems. And so that is actually something really easy. It's like not a huge big step, but that's what we have to learn today. So it'd be pretty simple. Let's say it was something like how many particles of CH4 are used to produce 8.2 times 10 to the 24th molecules of water. Okay, so first thing, I need my equation. This is just a combustion reaction, CH4 plus O2. And remember, the equation will be provided for you. Okay, first order of business is to balance this equation. 1C, 1C, 4 H's, 4 H's, 4 O's, 4 O's. Let me just make sure. 1C, 1C, 4 H's, 4 H's, 4 O's, 2 plus 2, 4 O's. Okay, so we should be balanced. So I'm going to recognize this as a particles A because we have molecules, which is my particles box, and A, which is going to be my water. 2 particles B, because it says, I made it say particles. I think I should actually make it say molecules. That's more likely what the problem will say. And I know it's particles B because CH4 is a new substance. So my B is right here. Okay, I'm going to start with the number in the problem. I'm going to do this down here so I have a little bit of space. 8.2 times 10 to the 24th molecules water, X in line. Okay, this is a particles A to particles B problem. So let's just track it on our mole map. 1, 2, 3-step problem. Particles A to moles A is my first step. So I know I have to go from molecules of water to moles of water. Remember, as long as we're not in the mole to mole step, the number in front of mole is automatically 1. And the number in front of molecules is always 6.02 times 10 to the 23rd. Molecules water cancels with molecules water. Moles H2O up here, so moles H2O down here. Okay, now let's see where I am. I did particles to moles. Oh, I'm in my mole to mole step. Remember, my mole to mole step is the only time I'm going to switch substances. I have H2O on bottom. That was my A. I need CH4 on top. This is my opportunity to switch from water to methane. Number in front of H2O is 2. I'm getting that from the coefficient. Number in front of CH4 is 1. I'm getting that from the coefficient. Moles cancels with moles. Excellent. Now I'm right here. One more step. I've just run out of space, so I'm just going to the next line. If I have moles CH4 up here, I need moles CH4 down here. And this time, let me see where I'm at. I did moles A to moles B, so now I'm doing my moles B to particles B step right there. So I have moles on the bottom, and I'm going to particles, which is molecules of CH4. Remember, I'm not in the mole to mole step, so that means I can go ahead and put a 1 right in front of my mole, and in front of molecules, 6.02 times 10 to the 23rd. Mole CH4 cancels with mole CH4. And now I'm ready to go ahead and calculate this. So I'm going to grab my calculator. And remember, I'm going to use my EE button. That's going to be really important. And so I'm going to go ahead and type in 8.2 E24 times 1 divided by 6.02 E23 times 1 divided by 2 times 6.02 times 10, E23 equals. And my calculator says 4.1 E24, but I'm going to go ahead and write that as 4.1 times 10 to the 24th molecules of CH4. Okay, and that is the answer. And that's us doing a particles A to particles B problem. So now you guys, you essentially know how to do everything on this map. We could do a simple mass to moles problem. We could do a little bit harder mass to, let's say, particles problem. Okay. Then we made the jump to be able to jump sides of this map. You could do a mass A to mass B problem. You could do a volume A, and now we know how to go to particles, so we could do a volume A to particles B problem. Essentially, you know all of stoichiometry and how to move all around this map. Now, on a test, for example, even if we were in school, I would allow my students to look at this map while doing problems. But as we got better and better at it, for example, in my AP class, students are not allowed to look at a mole map. But I do imagine that you guys can do many of these problems without the mole map at this point. Let's see, this video has been 8 minutes, so I think we have enough time to do one more problem. Maybe I'll give you a problem and you guys can go ahead and try it, like pause the video and try it, and then see if you got it right. Okay, so let me make up the problem for you. It's going to be this. How many liters of, we're going to use the same equation, so of CO2 are produced from 3.3 times 10 to the 25th, that's a 25 molecules of O2. Again, we're using that same equation we were using before. Oops, sorry, not CO2, that's CH4 plus O2 going to CO2 and H2O. And I believe when we balanced it, it looks like that. Okay, so go ahead and pause if you need to, so that you get a chance to try this problem. Okay, hopefully you identified this as a particles A to volume B problem, okay? And you started with 3.3 times 10 to the 25th molecules of O2. You knew this was a 3-step problem. I'm going to try to fit all 3 steps on one line. Let's see. 6.02 times 10 to the 23rd molecules O2. 1 mole of O2. 2 moles. This is my mole to mole step. And now just to my liters. Molecules, moles O2, moles CO2, CO2. All right. Throwing it into my calculator right now. 3.3 E25 times 1 divided by 6.02 E23 times 1 divided by 2 times 22.4 divided by 1 equals, and I am getting 613.95. So I think if I'm rounding to the tenths, I'm going to make that 614.0 liters of, what are we left with? CO2. CO2. Okay, awesome. So hopefully you guys are feeling comfortable with this. I'm going to go ahead and stop the video. Sorry that you can hear so much noise back here today. I would like you, please, today to complete the assignment called Stoichiometry, practice page number 3. There should be enough space for you to do all the problems, and that's a little bit of a mix. They're not necessarily all 3-step problems, so just make sure you take some time to figure out what they're asking you and make sure you do the right type of problem. Is it a 1-step? Is it a 2-step? Is it a 3-step problem? So just kind of double check. I do think the most challenging part of stoichiometry, page number 3, is actually balancing the equation up top, so make sure you take a second to do that. And then there is a place on Google Classroom for you to turn it in. I can look at it tomorrow and give you some feedback. I haven't had a chance to look at your assignments that you may have turned in this morning, so I will do that right now and send you feedback as well. Hope you're doing great. Remember, tomorrow I will see you guys on Zoom at 1 p.m. Can't wait to see you then. Bye.
Look what I did.